Okay, now we look at an example where an object, we're back to just analyzing vertical motion for a moment. An object is given an initial y velocity of 7 meters per second, accelerates at 9.8 meters per second squared for some time. We know that it falls 22 meters. We're trying to find the time. Now, all the velocities and accelerations are downward, so in this case, we're going to take downward as the positive direction. How do we find the time interval? Well, one thing we know is that the time required is the displacement divided by the average velocity. However, we're not given average velocity. If we know initial velocity, if we knew final, we could find average, but we aren't given the average velocity, so we've got to find it. And in order to find it, let's first find the final velocity using this familiar equation, the v0 squared plus 2a delta s. The final y velocity will be downward, very obviously. That's in the positive direction, so we're going to use a positive here. And this is what we're going to get. And here is the calculation, squaring the initial velocity, 7 meters per second, and 2 times acceleration of gravity times the 22 meter displacement, gives us approximately 22 meters per second. Therefore, the average y velocity we get by averaging initial and final gives us 14.5 meters per second. And our time interval will be the displacement over the average y velocity, which is 22 meters, over the 14.5 meter per second average velocity, or 1.5 seconds approximately. Now let's look at a variant here. This time the initial velocity is upward at 7 meters per second. The acceleration and the displacement are downward. Now when we have anything going upward, it's fairly natural to use upward as the positive direction, which would make the acceleration and the displacement both negative. We could have used downward as positive and made this negative, but that would be a little bit counterintuitive, and most people would have a little trouble thinking of it in that way, so we'll do it this way. The final velocity then is going to be obviously downward, which is the negative direction. The rest of the calculation is just as before, and we've determined that the final velocity is negative 22 meters per second. Now that's the same magnitude of velocity that we had before, but before it was positive 22 meters per second. The average y velocity is calculated just as before, but now the final velocity has an opposite sign from the initial, and we find that the average y velocity is negative 7.5 meters per second, from which we calculate our time interval by dividing the displacement by the average velocity. The displacement is negative 22 meters. The average velocity is negative 7.5 meters per second. And now the motion requires 2.9 seconds. So we see examples now. Here we've seen examples where the initial velocity is downward, initial velocity is upward, the acceleration and the displacement both being in the downward direction.